fourth summer video on limits. This is a direct continuation of video number 3, which started with how to find a limit algebraically, the 3 main ways. In the past video, I talked about direct substitution and dividing out. In this one, I'm going to talk specifically about finding a limit whenever there is a vertical asymptote at the point that you're approaching, or the x value that you're approaching. And we're going to have to end up using one-sided limits here to investigate what's actually going on. In this example, I have the basic rational function, x minus 2 divided by x plus 1. In this case, I am approaching negative 1. It's pretty clear to see that you can't use direct substitution. If you were to try, then you would get a 0 in the denominator, which obviously is undefined. Just be careful. Some people think that as soon as there is a 0 in the denominator, that there is a hole there. In this case, I have a number in my numerator. That means that there is a vertical asymptote at x equals negative 1. There's not a hole there. So to see what's actually going on with this graph, let's look at this graph here. So I have x equals negative 1. Now some people are tempted to right away say that the limit does not exist because there was a 0 in the denominator and we obviously can't divide by 0. But sometimes it's going to be necessary to look at exactly why it doesn't exist and what's actually happening on the left and on the right. So although the overall limit as we approach negative 1, there isn't really a limit because as we see the graph is unbounded there, it shoots up and it shoots down. We can look at the one-sided limits and talk about those. So the limit from the left and the limit from the right. What you need to remember is, let me just draw my horizontal asymptote quick of 1. As you approach a vertical asymptote from the left and from the right, the graph can only do one thing. It can shoot up and down. It can't go through it, and it can't just stop. So I should say it can do one of two things. It can shoot up towards infinity, or it can shoot down towards negative infinity. Your job sometimes will be to decide which of those two is it doing. Is it shooting up or is it shooting down? Now to do that, the technique that I always recommend using is taking a point that is very, very close to the vertical asymptote and very, very close to the x value that you're approaching. Now you don't want to pick like negative 3 because that's kind of far away. You want one that's very close, such as negative 1.1. So let's do from the left first. So we'll do this guy. Negative 1.1 is very close to negative 1 as you're coming towards negative 1 from the left. So the method here is plug negative 1.1 into the function and see what happens. So this is all kind of just scratch work here, but negative 1.1 minus 2 divided by negative 1.1 plus 1. The thing is, we don't even really need to find an actual number. We only need to know, is the output positive or negative as you get close to negative 1 from the left. So in my numerator, a negative minus a negative will be negative. In the denominator, negative 1.1 plus 1 is still negative. A negative divided by a negative is positive. So that means as I get closer and closer to negative 1 here, my outputs are positive. So you can assume, it's safe to assume that your graph is shooting up. So this limit is infinity, which technically isn't an actual limit because infinity is not a number, but at times you will be asked to state it like this. Let's approach it from the right. Usually it does the opposite, but not always, so it's always safe to check here. Let's pick a number close to negative 1 from the right this time. So I'm going to go ahead and pick negative 0.9. I usually pick a number that's 0.1 away, but you could do negative 0.99 if you wanted. So negative 0.9. Scratch work here. I'm going to plug it in. Okay, negative 0.9 minus 2 divided by negative 0.9 plus 1. Again, all I care about is it positive or negative? In the numerator, I have a negative. In the denominator, this time, I have a positive. And negative divided by a positive is negative. Whoa. There we go. Negative. So as I get closer and closer and closer to negative 1 from the right, my outputs are negative, so it's shooting down towards negative infinity. So if you have a rational function and there's nothing that you can cancel, so there's not a hole there, but they still want you to state a limit, especially if it's a one-sided limit. It's often necessary to use this method where you pick x values very close to your x value on the left and the right and see if it's shooting up or down. Just as a heads up, this method will be necessary on the second to last page of your summer work packet when it gives you a whole bunch of limits to find in that 2-column table. Number 7, specifically, you can anticipate doing this. It asks for the limit as x approaches -5 from the left of x minus 3 divided by x squared plus 7x plus 10. Because whenever you plug -5 in, you end up with -8 over 0, which means there is a vertical asymptote. So you're going to have to find from the left and pick a number close to -5 on the left and plug it in.